Well, I just want to thank everyone. It's good to be back and briefing the ROS community. As you know, as many of you know, but not all, ARM is a public-private partnership that is charged with really invigorating the U.S. industrial base through the adoption of robotic technology that, and I like to say that is enhanced with AI, although not all of it is enhanced with AI. And in achieving our mission, ROS really is a big tool that a lot of our consortium folk use. And let me just go over really a little bit more about us. So like I said, we're a consortium. We are now over 300 members. And our membership is vast. It includes almost all of the major OEM manufacturers of robots. And so we can get access to Yaskawa, to Fanuc, to ABB, to Universal Robotics. And then on the autonomous mobile robot and on the AGV side, Furio and Waypoint and IAM, as well as many others on the end of arm tooling, ATI and Push Corp, all members of the arms. And then at the university level, again, all of the major tier one research universities that are doing research in robotics and artificial intelligence as well are members of the arms. And then again, on the larges, it's Boeing to Airbus to Johnson & Johnson and GE and Raytheon. And then to the smalls, it's like, little Fumoro or other companies all over this country. So really a great institute in that regard in what we do. And we really spend a lot of our time developing technology. And I like to say the technical staff at the ARM are the members that actually engage and work on our projects. And we put out a lot of projects each year. So again, nature is this public-private partnership. Our grand vision, we don't make products at ARM, we invigorate the industrial base, but if we're successful, the future world will be a place where people and robots work together. And I'll read this part: to respond to our nation's greatest challenges, but I like to say to develop and produce the world's most desired products. And I think ROS has a big piece to play in that as well. As I kind of alluded, our method is we invest in technology. In fact, in 2020, we invested $36 million on over 30 projects. Many of those were for COVID relief and other areas, but others were ones that we developed along our roadmap. So we invest in what we believe is the most urgent and important technologies that allow for the use of robots in manufacturing. And I like to say, and logistics. Logistics is part of manufacturing. So again, all the robots you see on a factory floor that are fabricating things, finishing things, assembling things, inspecting things, moving things around the factory from the work cell to the stores, or from the work cells when they're finished goods to the warehouse, and then from the warehouse into loading and unloading trucks, packing and unpacking boxes, stacking and unstacking boxes. That's what we do. And I like to say when you spend time on a ARM project, which we pay for, and they're $500,000 of funding, that's really where we do our most important work, which was create an ecosystem, because people work with people they trust. And this is a great way to get to know other folk who are doing robotic technology. And we invest in workforce training, and we've been working harder and harder to try and get ROS into our training without duplicating what the ROS community does. In terms of our projects are competitive. We do at least two calls a year, very high probability of win. You have to be in a team. And we are in TRL level 4 to 7. And I just jumped ahead of myself in my thought. I just wanted to say very quickly, as a snapshot, we are a national institute. We are headquartered in Pittsburgh. We are just, if those who know Pittsburgh, we are right down the hill from CMU. If you're looking at it on a map, we're right next door, but it's about a mile vertical between us and CMU. And what's really interesting about our location and Carnegie Mellon University's location is within a 3-mile walk of our facility is over 75 robotics and artificial intelligence companies, both large and small. So it's one of the few places on the planet where you can go down to one of the restaurants or bars not too far from our facility. If you throw a rock, you will hit a roboticist or an AI specialist. So very interesting place to be working, and we have projects everywhere in almost every state in the nation. This is an older chart. So if you don't have a project in your state, it would be surprising. And where we actually do our research is, or our work, we are in the innovation gap. So all of our university members and our research community that operate at TRL levels, 0, nothing, to TRL level 3 or 4, we like to say is come see us when you get to level 4. We'll team you up with industry and other experts, and we'll help you get across what they call the innovation gap. So we fund projects to move from TRL level 4 to TRL level 7. Now, TRL level 4 says you have developed a prototype that works in a lab. And TRL level 7 says you've matured that prototype from working in a lab to where it works, in our case, a manufacturing environment. And we also say we look at MRL. MRL is called manufacturing readiness level. And the manufacturing readiness level 7 says that you have the capability to produce the system. You identified the components. You can procure the components, and you've tested it or produced it in a representative environment of a factory. So I like to say TRL says, will it work? MRL says, can you make it? There's another one called commercialization readiness level, which I'll talk about in a second. And CRL says, if you make it, will anybody even need it and buy it, and can you sell it? And so from a commercialization readiness level, we require all of our projects as we mature them from 4 to 7 to have solid business cases, to have an end adopter identified, and to have a major industry partner on the team. And right now, I don't have a slide on it, but I'll just tell you, I'm really proud. 33% of the programs we've funded and have finished are transitioning to either to the factory floor. And those of you from the state of Texas, and those of you from the Austin, Texas area in particular, we funded a project for COVID relief that in 4 months went from an idea. Well, I would say it was an idea. It was a working, they had the individual pieces working, went from an idea to a product that is now in revenue service. And that was Wilder Systems. I think it's called their Wilder Medical Group, who made a test kit for a robot, a test cell, which is a robot that quickly can do COVID testing. And I recommend everybody look it up. Significant amount of ROS in that project. So if you want to go from an idea to a product in 4 months, go talk to the guys at Wilder Systems and use ROS, because ROS was key to doing that. In terms of just giving you an overview of what we do at ARM and the types of technology we're developing. So again, everything from, I call it pliant material handling and assembly product, which is basically moving flexible and delicate things where it's not very easy to predict how it will move. And this is everything from a textile fabric in a garment to a flopping piece of as you can see here, if you can see my cursor on the upper right, they're putting together a windmill blade. And if you can see here right next to it, the robot video, that's a bunch of guys at USC and Gray Matter and Lockheed Martin and UTRC, now Raytheon. They're laying up multiple layers of carbon fiber for lightweight aircraft parts. So, lightweight aircraft parts, renewable energy, the big blades, and making clothing. One of our bigger successes is the one here that I'm drawing the circle on. It's a robot called SOBO, S-E-W-B-O. If you look it up, it's a neat video online. That is a high mix, low volume manufacturing robot that is a tailor or a seamstress. We've worked with SOBO and Henderson Sewing Machine and Blue Water Defense and Siemens, and mostly Berkeley, but also RPI on many of these textile programs, to now we have a point where a major manufacturing of rugged garments and fashionable garments is looking into using SOBO to manufacture in the United States. And when that happens, you'll see the press announcement. It will be a big deal. Other robots here is a 2-armed robot that can strip a wire and put an end connector on the wire. which sounds kind of boring, but it's a very, very difficult job because again, you have to strip a wire without damaging it, thread it through a piece, crimp the end, and then inspect it. And this robot can do it significantly better with less fatigue and less errors than a person that was doing the job. By the way, a job that they couldn't keep people doing because most people would quit after a few months. In terms of the automotive, aerospace, and electronics industry, again, laying up of carbon fiber on rotor blades to make them lighter and cheaper and quieter. Robots that are using force feedback or optical or both to do sanding of components and parts. Robots that are also using grinders to grind splines into gear trains. As well as factory logistics robots. And this one here is at a car auto manufacturer. It was a go fetch robot. And that robot would go and fetch a part, bring it to the installer, lift it into place, actually align it with the bolts and put it into place. And then the installer would actually put the bolts on. A very interesting project. By the way, this is one of our early projects done by the guys at Clemson. And in fact, also Siemens and a larger team. The technology we developed in this robot is being reused over and over and over again on other projects at the arm, and a lot of it's ROS based. Again, here is a snake robot or a multi-articulated non-anthropomorphic robot that cleans underneath or cleans in hard to get to areas. So it's a vacuum and inspection robot that cleans dirt out of, in this case, aerospace wings. This is another one of our successes that is going to go into the field. It's being investigated right now by a major aircraft manufacturer to put into their operations. In terms of heavy industry, again, grinding, sanding, polishing, surface treatment such as cold working, where we have a roller being put on a thing. Again, almost all of these is significant ROS, and I'll go into what ROS modules we use. So surface treatment and cold working of parts, either through rolling or through cold spray or through, in terms of disinfecting or making it a sterile, blasting copper to like a cold spray of copper to sterilize the equipment, and then thermal surface treatment as well. So just to give you this little pretty picture, kind of abstract, give you a good view of really what how the arm works. So the little circular balls, think of those as little ROS modules or modules of technology. We develop modules of technology that you build together to execute a manufacturing process. And that manufacturing process simply might be to join two pieces of material together, or to weld a seam, or to braze a seam. And that process could be used in both the aerospace market and the automotive market. So we invest in technologies that make manufacturing processes that can be used in multiple markets. And that's how we leverage our investments. So like I say, we invest in technology. It's not necessarily clear when you look at our roadmaps, but when you really just sit back and look at what ARM has done, we invest on a very, very specific strategy. And in this strategy, we've identified about 23 key technologies that if we develop these technologies will have the greatest impact with regards to being the most urgent and most important things. But those things will have the greatest impact on achieving our mission, which is that the industry adopts robotic technology, enhances it with artificial intelligence to make the US manufacturers the most competitive and the most desirable in the world. And for the DoD, they have a better supply chain, and they have not just improved proficiency, they may have improved efficiency in getting things. So again, we're funded by the DoD, but we're dual use. We're both commercial and Department of Defense. So the things that we really see as high use and things that we've developed are methods and tools for successful robotic adoption and expansion. These are things that help you do your business case. Methods and tools for streamlining integration, things that help you model when you put the robots down on the floor and lay it out, and methods and tools for assessing industrial readiness of a new technology. User-friendly interfaces for programming, operation, and maintenance, an area we're actually getting some good progress now. The robots are becoming easier to use. We've been building some user interfaces that are for paddles and programming devices. And then human robot trust and safety is better perception on the side of the robot to avoid an injury or to avoid damage. Plug and play software and standards, plug and play hardware standards, open source and open architecture software and methods. When I say master integration platforms, think of the industrial Internet of Things, and then metrics of interoperability. So we have a very large metrics working group. If you want to get an idea of what is good performance, we have that in a document we've been building over time, which is how do you quantify good performance of a robot when doing a manufacturing task? And then reconfigurable, agile, and flexible robotic systems. Again, so, look at this concept of modular robotic design where you can move the EOTs around, move pieces around, move motors around, especially moving software around. And then automated path planning and robot instruction generation. And then if you can see, almost everything we have for intelligent robotic systems is in the areas where we've identified as the most urgent and most important things to develop. And that's self-aware and adaptive systems, machine learning and artificial intelligence, distributed edge and cloud computing software, and advisor robots. And these are robots that help you do a better job at manufacturing. They're watching over your shoulder to prevent injury, to help you do inspection. They can see things that you might not see. And they help you in training you. So a robot can train you to do a better job at what you're doing. The other things that we do, which are not highlighted here, are also important. It's just that we see sufficient effort from the community that it's something we're not necessarily going to invest in unless it's one of those things that's a very compelling business case or is a big need to the DoD for a specific application. And just to give you some examples of ROS modules that were used on programs. So again, IPA coverage planner, navigation and move, swarm control stack, of course, move it, grasp it, the A5 software libraries, SMATCH, which is a task level. I see I'm getting some things on the chat. And robot behavior and no ether for geo-constrained path planning, discards, G mapping, the ROS-I. These are things that actually we've been developing. So we've been developing a DDS bridge, MT Connect bridge, and middleware wrapper layers, as well as what's available through ROS. And then just examples of projects we've used. And I'm talking fast, so I want to have time for questions. So again, we did a passive object tracking via multispectral robot sensor fusion package and semantic segmentation. That's a really large word for it. We built a robot that grinds splines into the central hub of a cog. But this cog is part of a huge power plant, so it's like 6 feet around. And we had to look in multiple spectra to actually see what we were doing and be able to do the job. In terms of the areas of autonomous mobile robots, again, we're using a lot of the software libraries for AMR interoperability, a lot of plug and play connectivity, which ROS supports, and then other compatibility through open APIs to reach more modules. We did a disinfectant mobile autonomous robot to go into a building and disinfect it. In fact, we've done 3 of these using different ways to disinfect, and one of them can go into the building and disinfect it while people were working. And that's for depots and work and hangars and other areas. And all of those use motion planning and path planning algorithms from ROS. Other things, I just talked about that one. And using ROS for robots to do surface treatments. So just to summarize before I open up for questions, the ROS, our view is, this is a quote, ROS shrinks the time to market by providing a trusted and well understood library of very useful packages, nodes, dashboards, and development modeling and risk reduction tools. I like it because that quote kind of came in for justification for one of our proposals. And I think it was a good summarization message of why ROS is important. I also believe if one desires to stay closed source, one could still use ROS on prototypes and pathfinders. and then recode what you finish or license it for a de-risk product to maintain that closed source state. And I really want to point out, I'd like to say almost every one of our projects that we've sponsored chose to use ROS. And I think, and when they highlight it in the proposal, they highlight it as a discriminator of why we should fund them. And because it's going to reduce the development risk because the ROS modules have already been trusted or pre-known to work. It allows for good reuse. It improves schedule because they don't have to develop it from scratch, and it significantly reduces cost. So that's really where ARM is with regards to ROS and why we love it so much.